Welcome back to our class. In the previous class, we have discussed the 8.4 exercise 1 to 4 problems, right? Now we will look at the problems from the 5. Fifth one, prove the following identities where the angles involved are acute angles for which the expressions are defined. First one, cosec theta minus cot theta whole square is equals to 1 minus cos theta by 1 plus cos theta, which means we need to prove that cosec theta minus cot theta whole square is equals to 1 minus cos theta by 1 plus cos theta. We know that cosec theta is equals to 1 by sin theta and cot theta is equals to cos theta by sin theta. Substituting these values here, we get 1 by sin theta minus cos theta by sin theta whole square. Here you can see that in the denominator sin theta is common. Therefore, it can be written as 1 minus cos theta whole square by sin square theta. And we know that sin square theta plus cos square theta is equals to 1. From here, sin square theta is equals to 1 minus cos square theta. Substituting this value, here we get 1 minus cos theta whole square by 1 minus cos square theta. And you can see that 1 minus cos square theta is in the form of a square minus b square, which is a plus b into a minus b. Therefore, 1 minus cos theta whole square by 1 plus cos theta into 1 minus cos theta. Here 1 minus cos theta, 1 minus cos theta get cancelled, and the remaining would be 1 minus cos theta by 1 plus cos theta, which is the required answer. And the next one, cos a by 1 plus sin a plus 1 plus sin a by cos a is equals to 2 sec a. We need to prove that this part is equals to 2 sec a, right? Here cos a into cos a is cos square a plus 1 plus sin a into 1 plus sin a is 1 plus sin a whole square by cos a into 1 plus sin a, right? And you can see that 1 plus sin a whole square in the form of a plus b whole square, which is a square plus b square plus 2ab, right? That is equals to cos square a plus 1 square plus sin square a plus 2 sin a by cos a into 1 plus sin a. And we know that sin square theta plus cos square theta is equals to 1. Here you can see that cos square a plus sin square a is in the form of sin square theta plus cos square theta. Therefore, it can be written as 1 plus 2 sin a by cos a into 1 plus sin a. Here 1 plus 1 is 2 plus 2 sin a by cos a into 1 plus sin a. Here taking 2 as common, we get 2 into 1 plus sin a by cos a into 1 plus sin a. Here 1 plus sin a get cancelled, that is equals to 2 by cos a, and we know that cos theta is equals to 1 by sec theta, therefore which is equals to 2 into sec theta, which is the required answer. Third one is we need to prove that tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equals to 1 plus sec theta into cosec theta, right? We know that cot theta is equals to 1 by tan theta. Therefore, substituting cot theta equals to 1 by tan theta, we get tan theta by 1 minus 1 by tan theta plus 1 by tan theta. Here taking minus common, we get minus of tan theta minus 1, right? That is equals to tan theta by, here tan theta into 1 is equals to tan theta minus 1 by tan theta. Here minus into plus becomes minus by 1 by tan theta by tan theta minus 1. Here tan theta will move to the numerator and becomes tan theta into tan theta, that is tan square theta by tan theta minus 1 minus 1 by tan theta minus 1, right? Here we can see that in the denominator tan theta minus 1 is common. Therefore, it can be written as tan square theta minus 1 by tan theta by tan theta minus 1. And here tan theta into tan square theta is tan cube theta minus 1 by tan theta into tan theta minus 1, right? We know that it is in the form of a cube minus b cube, that is a minus b into a square plus ab plus b, right? That is tan theta minus 1 into tan square theta plus tan theta plus 1 by tan theta into tan theta minus 1. Here tan theta minus 1, tan theta minus 1 get cancelled, and we will have tan square theta plus tan theta by plus 1 by tan theta. Here writing separately, we get tan square theta by tan theta plus tan theta by tan theta plus 1 by tan theta. Here tan theta will get cancelled, and in numerator there will be 1 tan theta, that is equals to tan theta plus 1 by tan theta is cot theta, right? And here tan theta can be written as sin theta plus by cos theta plus 1 plus cot theta can be written as cos theta by sin theta, right? And here sin theta into sin theta is sin square theta plus cos theta into cos theta is cos square theta by cos theta into sin theta plus 1. We know that sin square theta plus cos square theta is equals to 1. Therefore, 1 by sin theta into cos theta plus 1. And we know that 1 by sin theta is equals to cosec theta. 1 by sec theta is equals to cos theta. Therefore, sec theta into cosec theta plus 1. Fourth one is prove that 1 plus sec a by sec a is equals to sin square a by 1 minus cos a, and given us hint that simplify LHS and RHS separately. At first we will simplify the LHS part, that is 1 plus sec a by sec a. Writing it separately we get 1 by sec a plus sec a by sec a. We know that 1 by sec a is cos a, that is equals to cos a plus 1. And now simplifying RHS part we get sin square a by 1 minus cos a. As we know that sin square theta plus cos square theta is equals to 1. From this, sin square theta is equals to 1 minus cos square theta, that is 1 minus cos square a by 1 minus cos a, and it is in the form of a square minus b square, that is a plus b into a minus b, which is equals to 1 plus cos a into 1 minus cos a by 1 minus cos a. Here 1 minus cos a, 1 minus cos a get cancelled, and remaining would be 1 plus cos a. Here we can see that LHS and RHS values are equal. Therefore, 1 plus sec a by sec a is equals to sin square a by 1 minus cos a. And the next one is prove that cos a minus sin a plus 1 by cos a plus sin a minus 1 is equals to cosec a plus cot a. Right? Here, dividing numerator and denominator with sin a, we get cos a by sin a minus sin a by sin a plus 1 by sin a by cos a by sin a plus sin a by sin a minus 1 by sin a. We know that cos theta by sin theta is equals to cot theta, and 1 by sin theta is cosec theta. That is equals to cot a minus 1 plus cosec a by cot a plus 1 minus cosec a, which is equals to cot a minus 1 plus cosec a by cot a minus cosec a plus 1. And here multiplying and dividing with cot a minus cosec a minus 1, we get cot a minus 1 plus cosec a into cot a minus cosec a minus 1 by cot a minus cosec a plus 1 into cot a minus cosec a minus 1. Here in the numerator we can see that cot a minus 1 plus cosec a into cot a minus 1 minus cosec a in the form of a plus b into a minus b, that is a square minus b square. And in the numerator also we can see that cot a minus cosec a plus 1 into cot a minus cosec a minus 1 is in the form of a plus b into a minus b, which is equals to a square minus b square. Therefore, cot a minus 1 whole square minus cosec square a by cot a minus cosec a whole square minus 1. We know that a minus b whole square is equals to a square plus b square minus 2ab. Therefore, it is equals to cot square a plus 1 minus 2 cot a minus cosec square a by cot square a plus cosec square a minus 2 cot a into cosec a minus 1. We know that cosec square theta minus cot square theta is equals to 1. From this, 1 plus cot square theta is equals to cosec square theta. That is, substituting here we get cosec square a minus 2 cot a minus cosec square a by cot square a, and we know that cosec square theta minus cot square theta is equals to 1. From this, cosec square theta is equals to 1 plus cot square theta. Substituting here we get 1 plus cot square a minus 1 minus 2 cot a into cosec a. Here cosec square a minus cosec square a get cancelled, and here 1 minus 1 get cancelled, that is equals to minus 2 cot a by 2 cot square a minus 2 cot a into cosec a. Here taking 2 cot a common, we get minus 2 cot a by 2 cot a of cot a minus cosec a. Here 2 get cancelled and cot a get cancelled, that is equals to 1 by cosec a minus cot a. And here also rationalizing with, that is multiplying with cosec a plus cot a and dividing with cosec a plus cot a, we get 1 by cosec a minus cot a into cosec a plus cot a by cosec a plus cot a, that is equals to cosec a plus cot a by cosec square a minus cot square a. Right? We know that cosec square theta minus cot square theta is equals to 1. Therefore, cosec square a minus cot square a is equals to 1. Therefore, the answer is cosec a plus cot a. Sixth one is prove that under root 1 plus sin a by 1 minus sin a is equals to sec a plus tan a. Here, multiplying and dividing with 1 plus sin a, we get under root 1 plus sin a by 1 minus sin a into 1 plus sin a by 1 plus sin a. Here in the numerator 1 plus sin a into 1 plus sin a is 1 plus sin a whole square by, in the denominator we can see that 1 minus sin a into 1 plus sin a is in the form of a plus b into a minus b, that is a square minus b square. Therefore, it is equals to under root 1 plus sin a whole square by 1 minus sin square a. And we know that sin square theta plus cos square theta is equals to 1. From here we get 1 minus sin square theta is equals to cos square theta. And we can see that here 1 minus sin square a is in the form of 1 minus sin square theta. Therefore, we can substitute here cos square a, that is equals to under root 1 plus sin a whole square by cos square a, that is equals to 1 plus sin a by cos a. Writing it separately, we get 1 by cos a plus sin a by cos a, and we know that 1 by cos theta is sec theta and sin theta by cos theta is tan theta. Therefore, it is equals to sec a plus tan a. And the seventh one is prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equals to tan theta. Here in the numerator taking sin theta common, we get sin theta of 1 minus 2 sin square theta by, and in denominator taking cos theta common, we get cos theta of 2 cos square theta minus 1. And we know that cos 2 theta is equals to 2 cos square theta minus 1, and cos 2 theta is equals to 1 minus 2 sin square theta. Therefore, substituting cos 2 theta here, we get sin theta of cos 2 theta by cos theta of cos 2 theta. Here cos 2 theta, cos 2 theta get cancelled, and remaining would be sin theta by cos theta, that is equals to tan theta. Eighth one is prove that sin a plus cosec a whole square plus cos a plus sec a whole square is equals to 7 plus tan square a plus cos square a. We know that cosec theta is equals to 1 by sin theta and sec theta is equals to 1 by cos theta. Therefore, substituting here we get sin a plus 1 by sin a whole square plus cos a plus 1 by cos a whole square. And here sin a into sin a is sin square a plus 1 by sin a whole square plus cos a into cos a is cos square a plus 1 by cos a whole square. And in the numerator we can see that it is in the form of a plus b whole square, that is a square plus b square plus 2ab, that is equals to sin power 4a plus 1 plus 2 sin square a by sin square a plus cos power 4a plus 1 plus 2 cos square a by cos square a. Now writing separately, we get sin power 4a by sin square a plus 1 by sin square a plus 2 sin square a by sin square a plus cos power 4a by cos square a plus 1 by cos square a plus 2 cos square a by cos square a. And here sin power 4a by sin square a is equals to sin square a plus, and we know that cosec theta can be written as 1 by sin theta, that is plus cosec square a plus here sin square a get cancelled plus 2 plus here cos power 4a by cos square a is cos square a plus 1 by cos theta can be written as sec theta, that is sec square a plus cos square a get cancelled, and remaining would be 2, that is plus 2. And here we can see that sin square a plus cos square a, that is in the form of sin square theta plus cos square theta, which is equals to 1. Therefore, writing here 1, and we know that cosec square theta minus cot square theta is equals to 1. From here cosec square theta is equals to 1 plus cot square theta. Substituting here we get 1 plus cot square a plus 2 plus here sec square a can be written as 1 plus tan square a, that is 1 plus tan square a plus 2. And here we can see that 1 plus 2 plus 3 4 5 6 7, that is 7 plus tan square a plus cot square a, which is the RHS part that we required. And the ninth one is prove that cosec a minus sin a into sec a minus cos a is equals to 1 by tan a plus cot a, and given us hint that simplify LHS and RHS separately. At first, simplifying LHS part, we get cosec a minus sin a into sec a minus cos a. Writing cosec a as 1 by sin a minus sin a into sec a can be written as 1 by cos a minus cos a. Here sin a is the LCM, that is 1 minus sin a into sin a sin square a by sin a. Here cos a is the LCM, that is 1 minus cos a into cos a is cos square a by cos a. And we know that sin square theta plus cos square theta is equals to 1. From this, sin square theta is equals to 1 minus cos square theta, and cos square theta is equals to 1 by 1 minus sin square theta. Right? Now substituting these values here, 1 minus sin square theta is equals to cos square theta, and 1 minus cos square theta is equals to sin square theta by sin a into cos a is sin a cos a. Here sin a get cancelled, and cos a get cancelled, and remaining would be sin a into cos a. Right? This is the LHS part answer. And simplifying RHS part, we get 1 by tan a plus cot a. Here tan a can be written as sin a by cos a, and cot a can be written as cos a by sin a. Here sin a into sin a is sin square a, plus cos a into cos a is cos square a, by sin a into cos a is sin a cos a. And this sin a into cos a will go into the numerator, that is sin a into cos a by sin square a plus cos square a. And we know that sin square theta plus cos square theta is equals to 1, that is equals to sin a into cos a. Here we can see that LHS is equals to RHS, therefore cosec a minus sin a into sec a minus cos a is equals to 1 by tan a plus cot a. And the last one, that is 10th one, is prove that 1 plus tan square a by 1 plus cot square a is equals to 1 minus tan a by 1 minus cot a whole square is equals to tan square a. Solving 1 plus tan square a by 1 plus cot square a, here tan theta can be written as sin theta by cos theta, and cot theta can be written as cos theta by sin theta, that is equals to 1 plus sin square a by cos square a by 1 plus cos square a by sin square a, that is equals to, here cos square a into 1 is cos square a plus sin square a by cos square a by sin square a into 1 is sin square a plus cos square a by sin square a. We know that sin square theta plus cos square theta is equals to 1, that is equals to 1 by cos square a by 1 by sin square a. And here sin square a will go into the numerator, then it becomes sin square a by cos square a, which is tan square a. Now solving 1 minus tan a by 1 minus cot a whole square, here tan theta can be written as sin by cos, and cot theta can be written as cos by sin. And here LCM is cos a, that is cos a into 1 is cos a minus sin a by cos a, and here sin a is the LCM, that is sin a minus cos a by sin a whole square. Here taking minus common, we get minus of cos a minus sin a, right? Here cos a minus sin a get cancelled, and sin a will go into the numerator and becomes sin a by cos a whole square. And we know that sin theta by cos theta is tan theta, that is tan theta whole square, which is tan square a, is the required answer.